Okay, welcome to lecture number 31. Last lecture we have studied midpoint theorem, which is one of the important theorems in geometry. Today we will see one concurrency of altitudes. So to start with, we have to first define what do we mean by altitudes. In any triangle, if we draw line perpendicular to any one of the sides passing through remaining vertex. So in this case the vertex is A and the side is BC. So if we draw a line passing through vertex A and perpendicular to BC, that line is called altitude. Okay. Similarly, I can do it for segment AC and vertex B perpendicular. So this line will be altitude passing through B, and the third also I can draw line perpendicular to AB passing through C. And an amazing thing happens in triangle is that these three altitudes, if we draw of any given triangle, they pass through a common point. This is the theorem that we will prove. But in the lecture notes it is also mentioned what do we mean by median. So this is definition of altitude, definition of median. In any triangle, if you join vertex with the midpoint of the opposite side, then it is called median. Midpoint of opposite side. A, B, C is a triangle, and suppose D is a midpoint of BC, then AD is median. Okay. We have already seen concurrency of perpendicular bisectors initially in this lecture series, and at that time, if you recollect, what did we do? We drew two perpendicular bisectors, got the point of intersection P, and then showed that P also lies on the perpendicular bisector of third side. Before that, we have proved perpendicular bisector theorem number 1, theorem number 2, therefore we got these two segments equal, then we got these two segments equal, hence these two segments are equal and they are P is equidistant from B and C, and therefore it lies on perpendicular bisector. So, but the story was you draw two lines, get the point of intersection, and then show that the third line passes through it. That was the proof of perpendicular bisector theorem. Now, in the case of concurrency of altitudes, we are going to use concurrency of perpendicular bisectors. In any triangle, it is very interesting, in any triangle, we already know that perpendicular bisectors are concurrent. So, for concurrency of altitudes, what we are going to do is, we draw parallel lines passing through A parallel to BC, passing through B parallel to AC, and passing through C parallel to AB. Okay. Now, these three lines, because they are parallel to the sides of the triangle, will intersect. Let us call these intersecting points P, Q, and R. Then there are few sets of parallel lines in this diagram. Say for example, line AQ is parallel to BC, AB is parallel to QC, and therefore there are different parallelograms by the definition of parallelograms in this figure. So let us list parallelograms. Quadrilateral ABCQ is a parallelogram, quadrilateral ACBR is a parallelogram, quadrilateral BRAC. Now these two are same, but I am writing it deliberately differently because I am considering vertex B. So BRAC, BPCA, quadrilateral BPCA is also parallelogram. Then if we will consider vertex C, then CPBA, these two are same. Then we have CQAB, and if you observe this CQAB and ABCQ, they are same. So there are basically three parallelograms in this figure, and we have many different properties of parallelogram available with us, which shows that the segments AR is equal to segment AQ. A is the midpoint of RQ. Because of property of parallelogram, you need to discover that. BR is equal to BP and CQ is equal to CP. Okay, so they happen to be midpoints of corresponding sides of triangle PQR. So this is what is the figure now. Now when we are drawing definition of altitude, drawing a perpendicular through vertex A perpendicular to BC, but perpendicular to BC means perpendicular to RQ. Therefore, if I draw a line perpendicular to BC, which is perpendicular to RQ, passing through A, similarly passing through B, and similarly passing through C, these three lines are supposed to be altitudes of ABC and they are supposed to be concurrent. Now, pause the video, look into the diagram, concentrate and find out for yourself why these three lines, or maybe the rays in this case that we have drawn, will pass through a common point. Okay, pause this video. Now the answer. The answer is, basically if you look at them from ABC point of view, they are going to be altitudes, but if you look at them from PQR point of view, they are perpendicular bisectors. The rays that we are drawing are perpendicular bisectors of triangle PQR, and we have already proved that perpendicular bisectors in any triangle are always concurrent, and therefore altitudes of ABC will pass through a common point. These are perpendiculars here, of course it will be perpendicular here. If they are perpendicular here, then it will be perpendicular here, and so on. They are perpendicular here, hence it will be. Therefore, perpendicular bisectors are concurrent, therefore altitudes are concurrent. This is what is very interesting proof of concurrency of altitudes. You have to understand it well and try to remember. Okay. Our next theorem is concurrency of medians. We have already understood what we mean by median. If a vertex is joined to the midpoint of opposite segment, then it is called a median. And now we are supposed to prove in triangle ABC, if we draw median, then they are concurrent. Okay. So again, the strategy here that we will follow is that we will draw two medians and show that the third median passes through the point of intersection. Okay. So median passing through B is drawn, median passing through C is drawn. Let this point be E, let this point be F, and then you join this point of intersection P, which eventually we will call G, and extend. Then you will show that wherever this ray AG intersects segment BC, let if that point D is point of intersection is D, then to prove that D is midpoint of segment BC. Now, this is how we will conclude midpoint theorem, concurrency of medians. The strategy is you draw two medians, get the point of intersection. The point of intersection is G. Then try to draw line passing through A and G. And if it bisects BC, then bisecting BC means it is yet another median, and therefore medians are concurrent. So what are we supposed to prove? We are supposed to prove the point of intersection of ray AG with BC is midpoint of BC. Okay, pause this video, spend good amount of time on this. If you can show, nothing like it, but otherwise watch the next video. Okay, now the important construction here, this is out of box, and the construction here is to extend AG up to K such that AG equals GK. AG equals GK, and then join BK. Join BK and C. Okay, if we do this construction outside the triangle, then what we find is G is midpoint of AK, F is midpoint of AB. Therefore, I can apply midpoint theorem to triangle ABK. Triangle ABK gives me result FG is parallel to BK and FG is half of BK. These two results I get because of midpoint theorem. Similarly, if I apply to triangle ACK, I get result EG is parallel to CK and EG is half of CK. However, now you will notice that FG is GC because it is one line. So GC is parallel to BK and EG is BG. Therefore, BG is parallel to GK. This implies BGKC is parallelogram. BGCK is a parallelogram and hence diagonals bisect each other. This implies BC bisects or GK, let us write it like this, GK bisects BC. And hence the point of intersection D has to be midpoint. This is how concurrency of medians is to be proved. Now, additional result that we get over here is FG is half of BK, FG is half of BK, but the property of parallelogram says GC is equal to BK. GC is equal to BK. So FG is equal to half of BK and GC is equal to BK, therefore FG is half of GC. So G point actually trisects CF. G trisects CF. Similarly, we can prove G trisects BE. So the point of intersection is a trisection point of the two medians, and it is easy to prove that GD is half of DK because BC also bisects GK. Therefore, G trisects AD. So G is a point which is called centroid of triangle, which trisects the median in the ratio 2:1, 2 towards vertex, 1 towards side. So these are the two very important theorems in this lecture number 31. There are only 3 problems in the homework. I request you to solve them. Check whether you have understood these proofs or not. Go through the videos again and again and be ready for the next lecture. Thank you.